Hello viewers. In this lecture video, we are going to prove Gauss law. To prove Gauss law, a basic understanding of spherical coordinate system is necessary. Now let us consider a point charge Q is placed at the origin of a spherical coordinate system. A closed Gaussian surface has been constructed around the point charge. For a point charge, the closed Gaussian surface should be a sphere. A portion of the sphere has been considered and a small differential area ds is taken on the surface of the sphere. Now a vector d has been constructed starting from the charge distribution, that is from Q, crossing the small area ds. This is d vector. Here d vector represents electric flux density. This pictorial representation can be imagined like this. So this is the closed Gaussian surface. We are assuming that the charge plus Q is at the origin of this sphere. A small differential area ds has been considered on the Gaussian surface. A vector d has been constructed starting from the origin, crossing ds. Like this. Equation 1 shown here is the general expression for electric field intensity for a point charge distribution which has been derived using Coulomb's law. Now we shall use this expression 1 to prove Gauss law. So equation for electric flux density is defined as integral d vector dot ds vector. Now we shall find out the value of d vector and ds vector and we shall substitute in this equation and integrate. The relationship between d vector and e vector will be d vector is equal to epsilon naught e vector. We already have the value of e vector from Coulomb's law. So d vector can be written as q by 4 pi r square ar vector. Now the expression for ds vector. In a spherical coordinate system, ds vector can take three possible values. Now we have to select one among these possible values depending upon our problem definition. Now consider a closed Gaussian surface like this. If you move this ds all around the closed Gaussian surface, the value of r will remain constant, but the value of theta and pi will change. So our choice will be the third one, as the value of theta and pi changes. So we can write ds vector is equal to r square sin theta d theta d pi ar vector. Now we shall substitute this value here. So psi will be equal to integral q by 4 pi r square ar vector r square sin theta d pi ar. As it is a surface integral, we have to use double integral. R square cancels. Ar vector dot ar vector will be equal to 1. So we can rewrite this equation as double integral of q by 4 pi sin theta d pi. The limits for theta varies from 0 to pi. Pi varies from 0 to 2 pi. In this figure, this angle will be pi. This is the angle of theta. So to understand this, a basic knowledge about spherical coordinate system is required. So this will be equal to q by 4 pi integration of sin theta minus cos theta 0 to pi integration of d pi 0 to the limits varies from 0 to 2 pi. So pi will be equal to q by 4 pi, applying the higher and lower limits, minus cos pi plus cos 0 into 2 pi. So this will be equal to q by 4 pi into 2 pi. 4 pi and 4 pi cancels. So we can write pi is equal to q. That is, electric flux over a closed Gaussian surface will be equal to the charge enclosed within the closed Gaussian surface.